Multiple groups, including Seneca Creek Watershed Partners, monitor Seneca Creek, as well as local and state governments. And from the diversity of critters that all these groups and governments find, we can make assessments of how healthy the stream is and assess the water quality. And thankfully, based on a monitoring that we conducted this most recent Saturday, the water actually looks pretty good. So we, at least where we sampled, things are looking pretty good. And so here's some pictures that Mary Kay took at her outing. We had, I believe, 8 people who braved the freezing cold weather and the snowy ground, and were willing to dig through the stream and dig through buckets of water to find these macroinvertebrates. And so what exactly is a macroinvertebrate? Benthic macroinvertebrates are bottom-dwelling macroinvertebrates, which are any sort of invertebrate that's large enough to be viewed without the need of a microscope. And they're typically, but not always, aquatic larval stages of insects. There's also some isopods, some crustaceans, some just worms. So there's a variety of them, but the common factor is that they generally live along the bottom of the stream, and they are underwater. And so some examples include insect larvae, beetle larvae, dragonfly nymphs, and worms. And in this picture here, we've got a big collection of damselflies and dragonflies. So that's one of our larger examples. And then what's the purpose of this monitoring? We monitor because it provides data to support larger scale assessments of water quality and to engage the community in learning more about the health of their local streams. So for example, the macroinvertebrates that we sample have a wide range of pollution tolerance and pollution sensitivity. Some are extremely sensitive to pollution, and if the water is at all having trouble faced with pollution, has low dissolved oxygen, then they won't survive. So we won't be able to find them. And then there's others that can survive in just about anything. So if we're finding really nothing but the macroinvertebrates that can survive regardless of what's in the water, that's not a great sign. If we can't find anything, that's a really bad sign, or we're just searching wrong. Some other factors that can affect water quality, as I mentioned, are dissolved oxygen, pH can also affect it, and then salt, which is something that we'll get into later. And then I believe next week we will also be having a full conversation about salt with the Muddy Branch Alliance. And then all of this data that we collect from macroinvertebrates helps to illustrate the picture of how healthy our watershed is doing. That's the Seneca Creek watershed at a very small scale. But Seneca Creek is not an isolated system. It's part of the Potomac watershed, and the Potomac watershed is part of the Chesapeake Bay watershed. So this really is a much larger issue than just what's living in our streams, and can we fish there, swim safely there. And these water quality issues affect a number of different things, including the safety of our drinking water from things like pollutants and salt, or damaged ecosystems that won't support larger forms of life, such as fish, which can then affect, the community's use of the water for things like fishing. And with these considerations in mind, multiple groups have taken on the mantle of monitoring in Seneca Creek. So there's, as I mentioned earlier, there are three groups that sort of have taken up responsibility for monitoring Seneca Creek. The first is Audubon Naturalist Society. That's where I got my start with monitoring, and still that's who we went out with on Saturday. They monitor on a site on Riffle Ford Road, just past the gravel parking lot. That gravel parking lot used to have divots that could swallow up a sedan, but it looks like they are now fixing it up. So that'll be nice. And ANS monitors 4 times a year, and they use their own water quality monitoring protocol, which uses these D nets. They're about 1.5 feet, 2 feet wide, and you collect 20 samples. And we'll be going more over that process later. And then there's also the Isaac Walton League, Rockville, and Lois Green Sligo chapters. Both of these groups have been monitoring for quite some time, and my understanding is that the Rockville chapter monitors between Clapper Road and the Waring Viaduct, and the Lois Green Sligo chapter monitors up near Sligo Creek, which is part of our watershed. And they use the Isaac Walton League Save Our Streams protocol, which is for the most part very similar. The big difference is that they use a much larger net than ANS does. Same effect, both of them catch a lot of critters. And they monitor multiple times throughout the year, I believe 3 times. And then the newest entry into it is Seneca Creek Watershed Partners. So at our outing on Saturday, we partnered with ANS, and we conduct, some of our members also conduct irregular monitoring across the watershed. So we have a lot of data from just a huge number of sites that we're working to get all figured out and try to get some consistent monitoring across those sites as well. And then, as I mentioned, there's also some government monitoring. Montgomery County and Maryland both also conduct their own independent monitoring. They use a slightly different system. All the volunteer groups will go into the stream, collect samples, and identify just next to the stream. The government entities, they will just take a huge volume of samples, they'll pickle them in alcohol, and then they'll identify them under much more advanced microscopes, and they'll identify them with a more precise level of taxonomy. So that they're also doing important work. Their level of identification is well beyond what I am personally able to do. And then how do we monitor the creek? And this is specific to the ANS model. I've taken the Isaac Walton League trainings, but I've not personally done it. So I'm going with what I'm familiar with. So we select 20 samples, 1 by 1 foot from a preset 75-foot stretch of the stream, and we empty those samples into dish pans. Most samples come from riffles, but we also sample along root wads, logs, and leaf packs. And Seneca actually has some pretty great root wads and leaf packs. So we do more of those than other sites use, just because they are so productive. And some of the riffles can be pretty fast in Seneca. So though they aren't nearly as productive as they always are elsewhere. And then after 20 samples are collected, the volunteers return to shore, and we spend the next hour or so pulling out any macroinvertebrates that we can find. We merge them together and randomly select them until we have hit 100, and then we mark down each different type that we found and the number. And then since it is random, sometimes you can lose something, really interesting or really unexpected, just through randomness. So we'll also make a note of that. If we found something extremely sensitive like a water penny, that would merit a note on its own. And this is just sort of a generic image of a stream to illustrate how we select where we're sampling. The riffles are where you see rocks coming out of the water. It's where the water is speeding up after a curve in the stream. That's where you find a lot of things like riffle beetles. And then we don't use pools nearly as much unless there is a root wad in them or some other reason. The critters just, they're harder to find there. You don't get the current and just pushing them into your nets, and a lot of them just don't live there. So that's sort of how we select the 20 species that we're going to monitor. And then what is in Seneca Creek? So there are fish, waterfowl, and amphibians. And then, of course, the reason why we're here, there are benthic macroinvertebrates. As a moderately healthy stream, Seneca Creek hosts many of the benthic macroinvertebrates local to the region. And the next slides will introduce the basic categories of these. If anyone is interested in learning more beyond what we will be covering here, I can't recommend the Isaac Walton League and Audubon Naturalist Society trainings enough. They're both excellent. They both cover all of the macroinvertebrates in the area in extensive detail. So I recommend checking those out, but we're thankful you're here. This is the 101 of benthic macroinvertebrates. And then if anyone is an expert on, fish, waterfowl, or amphibians or reptiles in the creek, please let us know. That's not something that I have much knowledge of, but I think we'd definitely be willing to set anyone up with a talk if they are an expert in that. So the first class of macroinvertebrates that we will start with is mayflies. This is one of our most common forms of macroinvertebrates in the stream. They range quite a bit in size and shape, but it can be anywhere from 2 millimeters to 20 millimeters. Our most common are baited mayflies or small minnow mayflies. These are tiny little mayflies. They swim around, I believe, in the corner. You can see under the corner of the second picture, you can see a little kind of dot next to that bigger macroinvertebrate. That, I believe, is a small minnow mayfly. to get the scale, and that other mayfly it's about the size of a fingernail. It's not big. So these things are tiny. They swim around very quickly. The fourth image, that's a flat-headed mayfly. Those are also fairly common. They're much larger. And then the first two images.
Not live.
It is live.
Yep, this is live. So the first two images are I believe, a spiny crawler and then a brush-legged mayfly. And brush-legged mayflies, we get a lot of those in our creek, and those are a good sign because those are fairly sensitive and they look pretty cool. Some notable characteristics of mayflies are that they typically have 3 tails. Some have 2, but most of the time they have 3. And they have these very pronounced gills. You can really see it with that second image, the brush-legged mayfly. There's the sort of like little fin. They look like tiny little fins all along the side, and those are gills. And when you see them in person, in the water, they're flapping those gills constantly. And so it's fun to watch. They really are a unique little macroinvertebrate with how visible and how active the gills are. And we like seeing these because they are moderate to low. They're fairly sensitive to pollution. They're not the most sensitive, but they're a good sign, and they're one of the base macroinvertebrates used to assess water quality. Stoneflies are one of the big reasons why we just went out this last Saturday. Stonefly larvae are found in Seneca Creek, most commonly in winter and spring, and really most commonly in winter. These are a fairly ancient critter. They've been around on Earth for quite some time, and they're fairly sensitive to pollution, generally more so than even mayflies. Their big defining characteristic is they have these 2 double wingtips. You can see those especially on that third image. You can see where the wings are going to come in, and you can sort of make out that there's 2 of them. On the third image, the second one is quite small. But the middle image, you can also see them. It's kind of in the middle between the last and the second to last set of legs. So the stoneflies, they're really only around in winter and spring. They also have very long antennae, and they've got fairly pronounced eyes. The images below, we've got a winter stonefly, a common stonefly, and another winter stonefly. And the winter stoneflies, you can tell because they've got these tiger stripes running down their abdomen. Caddisflies are another one of our most common macroinvertebrates, and these are probably the easiest to find just if you're out and decide to pick up a rock in the stream. These guys like to build, the most common are net spinning caddisflies, and they like to build little nests out of silk where they catch little pebbles and debris, like pieces of wood, pieces of algae. They catch it all in their nets, and they just kind of burrow within them. These aren't like hardened nets, but you sometimes have to pick through it to find them if you're picking up a rock. But the net spinning caddisflies are moderately tolerant of pollution. Most other caddisflies are fairly sensitive to it, though. So we've got the first 2 images show net spinning caddisflies, and then there's another type of caddisfly that makes a little house for itself. These are the casemaker caddisflies, and we've got examples in 3 of the pictures. The first one has a net spinning caddisfly sitting on top of another casemaker caddisfly's case. You can't actually see the caddisfly in it. But the second one, we've got an image where the caddisfly decided to actually come out and say hello to us while we were taking pictures, which we always appreciate because it's otherwise difficult to tell what they are. So that's the third image. And then the fourth is a collection of case-making caddisflies. The convenient thing about them, they're hard to find, but when you find one, you usually find quite a few. They seem to sort of create little colonies on the same rock. So when you find one, you know to keep looking at all the little twigs in the bucket. And most caddisflies have these, their distinguishing characteristics are that they have armor-plated heads. You can kind of see that in the second image where the head is a little darker than the rest of the body. And they also have these brushy gills running all along their abdomen. Obviously with case makers, it's hard to see all of that because they're hiding most of the time. And then our next category is beetles. So we have a variety of larval and adult beetles in Seneca Creek. The most common beetles are riffle beetles, which are typically very small. I believe the first and the third image at least are riffle beetles. And we find both their larvae and their adult forms. Interestingly, the larvae are basically the same size, if not sometimes a little larger, it seems, than a grown riffle beetle. So those indicate moderate pollution, that they can survive in moderate pollution, but they're fairly sensitive. Other beetles tend to be very sensitive. The last image is a predaceous diving beetle. Those are always exciting to see because they are fairly sensitive to pollution. And then there's some beetles that we don't see. Water pennies are the easiest example. Those are probably the most pollution sensitive macroinvertebrates that we have in our region. And I personally have never seen them at Seneca Creek. I would have to ask with some of our other volunteers if they've seen them before I joined the team. But generally speaking, I believe those are mostly only seen far up county in Montgomery County, potentially even out in Frederick County. Those really, anything in the water, and they're not around, unfortunately. But maybe one day we'll see one. And then dragonflies and damselflies are our next category. These are our first very large macroinvertebrates. These are ones where you don't need a microscope to tell what they are usually. They're large predators. I think most people have probably seen adult dragonflies and damselflies. They've typically are quite colorful, have some color, buzz around in the summer. Their macroinvertebrate form is also quite distinct. They've got long limbs. The dragonfly nymphs have a flat body with very short tails. They can be quite wide, and damselflies are sort of the opposite. They've got a long body and they can be quite long. And most all of these are moderately tolerant to pollution. In less healthy streams, you might see a couple damselflies, dragonflies, but if you're getting a lot, that's usually a pretty good sign. And these are also some of the ones where we have to keep them separate from everything else, because otherwise our specimen count drops. And even when we do keep them separate, we sometimes find them with no legs if they've been with each other. So they're not the nicest, but they don't bite humans, to my knowledge. And on the topic of frightening macroinvertebrates is our Coryidalidae. Our most common form is Dobson flies. These things are very large. These things can be, finger sized, like adult finger sized, and they're among the largest of the ones that we collect. They are predators. They have very nasty looking jaws. Like they look like they would hurt to bite. I've heard that they do not bite and that the mandibles are basically cosmetic in the macroinvertebrate form. I don't trust that. I'm not going to put my finger next to that. But the way you distinguish a Dobson fly from other Hellgrammites is that they have these brushy gills that you can see in the image on the right. At their bottom, they also have the filaments. They look like little legs running all along the body, but those are not, like, they do have 6 legs, but everything else is a little filament. And these are moderately tolerant of pollution. We tend to get quite a few of these in the warmer seasons. And they are definitely ones that you want to keep from the smaller macroinvertebrates, or you will lose a couple. And then potentially a little less exciting and dramatic from the giant hellgrammites are flies. Flies come in a variety of different forms. They typically have soft bodies, generally no legs or wingtips, and they range from among our smallest macroinvertebrates to among our largest macroinvertebrates. Our most common is a midge. These are tiny little worm-like things. I don't think I have any images of them. They're best identified in water because they just kind of flail around aimlessly in the middle through water. It can be up to half of what we find will be midges just because there are so many of them. Black flies, which we have a couple pictures of, are also worm macroinvertebrates. They are very tolerant to pollution. The image on the left and the two images on the bottom, those both have black flies in them. The larger critter, I believe, is a mayfly, but the one to the right of that is a black fly. It has sort of a bulbous end and a small sclerotized head, or a small armored head. And black flies tend to cluster together, so if you find one, you'll find quite a few. And then the last notable fly here is the crane fly, and that is in the picture on the right. These things can be as big as a Dobson fly, the ones that we just mentioned, but they are about as harmless as you can be. The only real harm they present is that one of their favorite things to do is crawl out of water samples and land on the ground. So not a lot of self-preservation. They just kind of, they're a little dopey, but they're easy to find at least. And most every fly is fairly pollution tolerant. In a really unhealthy stream, you'll find mostly flies. In Seneca, we find, what you would expect, a normal amount. And then some others that we find, they aren't as easily classified. We find flatworms, which are the image on the left and the bottom image on the right. These, we generally refer to these as planaria. They're sort of goofy looking. They've got weird little, they're not eyes, they're light sensors, but they look like cross-eyed eyes in their heads. And so it always looks like they're staring up at you, kind of scared. They're pretty cute. They're harmless. They're very pollution tolerant, but they're fun to find. And they're another one where if you're just picking up rocks in a stream, you'll often find one of them just slithering around. We find crayfish. We found a crayfish on our last outing. We find aquatic worms, which are like earthworms, but usually a little thinner, a little longer. We've got one of those in that third picture on the bottom. And then scuds they're amphipod crustaceans, and they zoom around on their side. And we found, I believe, more scuds than anything else on Saturday. They are moderately tolerant of pollution. I'm not sure why we found so many. We don't usually find as many as we did, but I think we must have just hit a nest of them. And we also were lucky enough to find one that was carrying its young in it with it. So that picture is not on the slideshow, but it is on our Facebook page if you'd like to see. And a scud is actually on the top right, and the one with the black dots in it, that one is not carrying its young. That one is carrying the eggs, I believe. That's not from our most recent outing. That's from a different outing. And then we also find sow bugs, which have many legs, and they're kind of covered in flat armored segments. They're like roly-poly bugs that you might find on land, but these ones are in the water. And so that covers the common macroinvertebrates that we have in our stream. Yep. So what else are we looking for? We collect our macroinvertebrates. What else are we doing while we're out there? We look at water level. We look at the speed of the flow of the water. We look at the quality of the stream banks, which can be important because you don't want the stream banks to be falling into the stream. We take a look at invasive plants that are along the stream edge. We We look at the form and variation of the substrate. The substrate is the rocks and the cobble and the boulders and the pebbles, everything that's at the bottom of the stream that the macroinvertebrates are going to live in. We look at pH, water, and water temperature and salt levels. Temperature doesn't play a huge role, but the pH and the salt level definitely can. We look at the presence and distance of human development. That can be anything from a walking path to a road to a housing subdivision. Any development is going, any human creation is going to somewhat affect the water. Obviously, there's variations on magnitude though. And then we also look at dominant forms of vegetation. So are we monitoring in a field? Is it a forest? That all can sort of affect the overall health of the local ecosystem. And then this is the sheet that we fill out. We fill this out every time we're out. This largely covers the topics that I just discussed. There's generally not a lot of variation, at least where we typically monitor at Seneca Creek. The one big change that we've noticed is that there was this nice tree. It was, I don't even think it was alive. It was barely alive, but now it is not, and it's been partially removed, and the bank around it has shrunk. So we've lost a really productive root wad. So that's the one big change in the site that we've seen. Otherwise, their numbers stay pretty consistent. And then here's an image of where we sample. You can see that tree. It looks like it does have leaves to the right. That's the one that has that good root wad. And as anyone who was there this weekend can attest, that tree is, that the gravel bank is now extending around that tree. So that's unfortunate, but we have this nice overturned tree in the water that always gets quite a bit of life to it. And then you can see some sticks next to the underturned tree. That creates a nice ripple where we can get a lot of samples as well. And then here's another image. The image on the left is the site. You can see that tree with the good root wad in the right side of that image. And then the image on the right, that is actually Muddy Branch. This image, it does have a nice, the Muddy Branch image on the right does have a good riffle going there from kind of that downward area, and it has a nice root wad, but the channelization that you see there, where there's an island in the middle of the stream, that's usually not a good sign. Generally, you ideally would want the stream to stretch from bank to bank. And then another thing we look at that I've mentioned is salt. Seneca Creek Watershed Partners and Audubon Naturalist Society both partner with the Isaac Walton League Salt Watch program to measure salt watch levels in our streams. Salt watch calls for measuring salt levels after roads are salted and also taking a sort of a base sample before salt goes down. We're going to be having a talk that I'll mention later on with Muddy Branch Alliance about salt monitoring in Montgomery County. But for purposes of our Seneca Creek site, we place a salt test strip in a sample of stream water and wait for the results. On Saturday, our salt was at 227 parts per million, which is high for our site. Our site is not near any major roads. It's not near any major bridges. So it's normal that we have a very low level of salt. For comparison, to get a basis of, if you aren't familiar with salt levels, Muddy Branch under 270 was sampled at over 1,000. This after this most recent snowfall that we had in Maryland. And you can see on the image that I took there using an electronic monitor, Muddy Branch was 911 parts per million that day. So all things considered, it's pretty good, at least by Riffle Falls Road. We would probably benefit from having some testing done near bridges and road crossings. I think right now this is just sort of a black area for data that we have. We would benefit from learning more to see if it is similar to Muddy Branch. And then our results from this Saturday, 7 of us braved the cold weather to go out. Like I mentioned, higher salt levels than previous years, but despite that salt level, our tolerance index score was actually very good. especially for what you would expect. Seneca Creek has had a rough year this year between the higher salt levels, the sewage leak that caused us to miss a monitoring session this year. So we really weren't sure what we were going to see when we went out, but it was thankfully, it was a good score. And so here is the calculated value. I took this with the Stroud water quality calculator. There are many different places that offer this same calculation. I went with the first one on Google. Another option is the ANS IWLA Creek Critters app. That one also has a very simple, easy to use system to calculate your scores. And then looking forward, Seneca Creek Watershed Partners is exploring ways to expand monitoring of our watershed. We have a couple of volunteers and board members who have experience with monitoring, and we'd like to get more. We'd like to bring more people out to the stream to see what's in it. We'd like to expand the number of sites. As I mentioned, it would be helpful to get some salt data from heavier used roads. And then we're also looking at some other metrics that we can look at, including microplastics, which is a big issue these days. So it would be helpful to know what's in our stream in terms of microplastics and other trash. That's something that requires some more advanced tools. And then if you're interested in getting involved, we've got links to the Isaac Walton League and the Audubon Naturalist Society trainings. Both are online. They're both easy to attend just whenever you're free. And if you would like to get involved, please send our main email address an email, and they will get us in touch, and I can add you to our scheduling email that we use for when we go out to monitor. There's also the Salt Watch Pledge. If you take that, you sign up for it, and Isaac Walton League will mail you a packet of Salt Watch strips. So if you live near Seneca Creek, if you are frequently by a heavily trafficked road and could help us fill in some of the gaps of how salt looks like elsewhere in the stream, that would be great. And then easiest way, download the Creek Critters app on Android or Apple devices and check out what lives in your stream. We use nets. You can just pick up rocks if you want. It's that easy. So thank you for attending, and any questions?
Hey, Kevin, this is Lauren.
Hey, Lauren.
That was awesome. Thank you. I learned a lot. I'm wondering if you have any idea. I think Debbie kind of asked the question in the chat about had anybody sampled the headwaters, and I'm sort of curious, how the macroinvertebrates vary relative to how highly developed the area is around the stream. How much impervious surface, I guess, might be a good measure to compare or something like that. Do you guys have any idea what that looks like?
On Seneca Creek specifically, no. Generally speaking, at least my understanding of where things are sampled is if the headwaters are sampled, it would be the state and county, and we don't have direct access to their data. I can tell you, I also monitor at Little Falls, which is heavily developed, is a fairly almost urban area, at least very suburban area. And it's I think everyone who's been there would agree it's bad. It's not a healthy stream. There are frequent seasons where we go out and we aren't able to hit 100. There are times where we get nothing but the most tolerant of fines. I think everyone who's there would like it to be better, but that's sort of what you get when it is more developed. And I also used to monitor in Arlington County with some of their more developed areas, and it was similar, where you get a lot of flies. There was one day where we only got planaria. We got 100 planaria. It was dreadfully boring, but with the more developed areas, you do typically see, at least in my experience, you see a drop off in what you're finding, especially compared to a site like Seneca. And then if you go further north up county to like Wildcat Forest, that's where you might actually see things like water pennies. That's where it's going to be the most pollution sensitive macroinvertebrates that you can find in the county. ANS used to conduct its training at 10 Mile Creek because that's a site that is very healthy generally.
Thanks.
Yep.
Kevin, this is Mary Kay. I just want to say thank you. It was a wonderful talk, and to reiterate what you've said about that we are very welcoming that we would love to have additional volunteers doing sampling or monitoring of the stream, but also if this task seems a little daunting, we have lots of other things that a volunteer could do. So please consider joining our group. It's free, and it's really great to get closely acquainted with the stream that you live near, because it's such an important part of the ecosystem that you live in. And I'd also want to just do a plug for, we are hosting another talk a week from tonight that will be by Carl Van Nest about salt monitoring. Okay, so sorry, Kevin, I jumped the gun.
No worries. I was about to turn to that if there were no more questions. So it's great that you brought it up.
Okay, so a week from tonight, co-hosted with the MBA, we'll have a talk on salt. And Carl's an expert on this, and there's really a lot to know about. So invite your neighbors to this one and share the word, please. Thank you. And then we can continue to ask questions.
Yep.
Kevin, this is Greg Trilling with Audubon.
Hey, Greg.
How are you? So
Good.
I put a note in chat. I don't know if you're sharing a screen, you probably can't see it. While you were talking, I went to our database. We found water pennies. You're right. They're really rare to find in that stream, but they were noticed, observed in 2007, 2010, and 2018. So you do have something to look forward to in the future. When you
Okay.
pick some up.
So we
Yeah.
It sounds like we have something to look for now. We have a goal.
Yep. And that's a trout stream, right? That's where they stock.
Yeah, and so especially in the summer, right when they stock, you can tell if there's an overlap in our monitoring and the recent stocking, because it is full of fishermen, and I don't think they love when we go stomping through the stream, but we try to get out of there as quickly as possible, and hopefully it attracts the fish to them.
But they wouldn't be out there if that stream wasn't in pretty good shape.
Yep.
Thank you for this tonight. It's great.
Yeah, and thank you for joining.
And before people leave, I'll just do another plug that we now have a website, senecacreekwp.org. And on that, we had talks similar to this last year, and 3 of them have been recorded and are there for you to look at if you're interested. They're very good talks, and we'll be posting this one online also.
Any more questions?
Thanks, Kevin. That was awesome. That was really good. Thank you for that.
Thank you.
I couldn't make it last time.